Welcome to Be Smart Together. I mainly focus on Power Query and Excel. May cover the Power Platform in future videos. If you're new, please make sure you subscribe and turn on the notification. Also, feel free to drop a comment to provide feedback, ask questions or let me know if there are any Excel, Power Query, Power Pivot or Power BI topics you're interested in. Today, I want to explain the custom function and show you a few examples on how we can apply the custom function. Let us start with a blank query. Name the query, function. Before we start, let me briefly explain what is the syntax structure of a custom function. The custom function consists of an optional parameter and the return type within an open and a closed parenthesis, followed by an equal and a greater than operator, then the function body. Here is a sample syntax. If you invoke the function, you will get an error, because there is no content. Delete the invoked function. Add x as the parameter name, and you will get a parameter input field. Replace the 3 dots with x. Type the number 1 in the input field and then invoke the function. The result is 1x is the input as well as the output, which is stated in the function body. Delete the invoked function. Let's add another parameter, and update the function to x plus y. Enter 1 to each of the input fields, and then invoke the function. The result is 2. When you didn't declare the return and it shows optional. Let's add the return type, x as number type, y as number type. The header, optional is now gone, and you will get an example in the input field. Enter 1 to the x input field, leave the y input field blank, and then invoke the function. Click on the error icon. You will get an error message, please specify a value for y. Add the keyword, optional to parameter y now, you get the optional header back. This means the parameter y is an optional field. Enter 1 to the x input field, leave the y input field blank, and then invoke the function. Now you get no error, but the result is null. Because null plus any number is equal to null. We need to add a conditional statement to the function body. If y is equal to null, then x, else x plus y. Check the result, it is now 1 instead of null. Let's delete the 2 invoked functions and add an example table. I want to show you how to apply the function with a simple example. Go to the Add Column tab and click on the Invoke Custom Function. Select Function from the drop-down list. Click on the parameter y, and change the decimal number to the column name. Then, select column y from the drop-down list. Click OK. A new column is now added, adding the x and y columns. Let me show you a different example. We have a daily sales table and want to write a custom function to get an accumulative sum. Use the group by function to sum the sales by date, ensuring the uniqueness of the date. Click OK. Then sort the sales date column in ascending order. Add a custom step. And delete the default code from the formula bar. We want to use the List.Accumulate function with 2 variables to calculate the cumulative sales. The first variable is row count. Use the table row count function to count the number of rows and then close the let expression. The second variable is to get the list of sales. Use the table denote header function. Then update the output step. Go back to the second variable, add the table skip function to skip the first row, and add the column 2 name at the end of the code. We demoted the header and skipped the first row, so we don't need to worry about any changes to the column name. The third step is the cumulative sum. We want to use the List.Accumulate function in this step. The first argument is the list of row numbers, and an empty list for the second argument. The last argument is the accumulator. Write x and an empty list. Add the list first end function to the empty list. The first argument is the sales list, and the second one is y. Copy the cumulative step name, and replace the output step name with the copied name. Preview the lists, you will see incremental sales rows in each list. Now add the list sum function to sum each of the lists. You now get a cumulative sales list. We need to update the output a bit. Turn the output into a list. Copy the highlighted code, paste it to the output step. And update the column name from 2 to 1. Do a quick preview. Lastly, use the table from columns function to turn the list into a table. The first argument is the list and the second is the column name as a list. We also need to define the data type. Go to the advanced editor, and it is time to convert part of the query into a custom function. The last step is the change type step, so we need to update the output step. We then cut the cumulative calculation steps as highlighted. Remove the last step, comma. Saved and exit advanced editor. Create a blank query. Named the query function cumulative sum in short form, and go to the advanced editor. Replace the highlighted code with the code we cut from the previous query. Update the output step name. Add the custom function syntax at row 1. We will need 3 parameters: previous step as table, date as text, and sales as text. We need to update those codes. The previous step parameter is the input to ensure the step continue. The date and sales parameter are to instruct the code which columns contain the information. Let's update the sales date with the date parameter. We need to replace this static code with the record field function to create the dynamic flow. Now update the highlighted code with the previous step parameter. The highlighted code, source overwritten the original code when we paste it across. Point it to the sorted row step. Same for this one. Here is another overwritten code. We need to point it to the sorted row step. Let's test the function. Select the example table from the drop-down list. Dates column name is sales date, and sales column name is sales. Awesome. It works. We can delete the invoked function. Add a custom column. Let me show you how to create a rolling total by week, month, quarter or year. Firstly, we need a conditional statement. There is a list of date logical functions available. Those functions can help you to determine if the date is fall in the current week, previous month, or current year. Let's test if the sales date is in current week. If true, return current week, else return previous weeks. Now we have a column help us to differentiate whether the sales date is in current week. The next step is to group the row by the newly added category. Select all rows from the operation drop-down list. As usual, delete out the unnecessary codes, then preview the table. Watch carefully, here is where we're going to apply the custom function. The underscore represents each table. Preview the result. The sales amount is accumulated. We can now expand the columns. Untick the prefix. Ta-da! Here is the awesome result. Thank you for watching, and I hope you find this video helpful. Please don't forget to click like if you like the video.